So before break, we started with trig inverses. We'll do a little bit of review, but what we did that Wednesday through Friday before break, you guys seem to have a pretty good grasp on principal values. So we'll review that a little bit, and then we're really not going to cover anything new, except for the fact that we're bringing in a little bit of calculator work. Really not a whole lot today, but tomorrow we're going to be building off of, because we do degrees first, just because it's a little bit easier visually. But then when we get down to radians, we're going to apply the same thing. But instead of 180 and 360, we're going to be dealing with pi and 2 pi. So, and then we should be able to get in some good review tomorrow as well. Quiz over trig inverses just over these sections on Wednesday. Okay. And then we're going to move on to solving trig equations. We'll have the rest of this week as well as most of next week to review or to go over those types of problems and review. And then our final test will be next Friday. And this is really the last day I'm going to have class, because after this, there's no more grades that go in the grade book, except for those who want to come in for extra help, want to do recovery, or if you missed this day of the test and you're coming in to do makeup, then I have this whole week reserved for that. Okay, so, for most of you, this will be the last day that you're required to be here. Well, I'm not so sure about Monday and Tuesday. I'm not so sure about the attendance for those days, but as I get more information, I'll share that with you guys. Okay. But I'm not going to have any class in terms of if you miss these days, it's not going to impact your grade, basically. Okay. Okay, if you guys can turn to page 7. We're on page 13, I know, but just want to do a quick review of principal values. So page 7, principal values, we talked about how if we're talking about inverse sine, if you see uppercase S or uppercase A, we're looking for values that are in the fourth and first quadrant for sine and for tangent. Okay, this will guarantee that we're going to get a positive or negative value, all represented, the entire spectrum represented. But the strange thing about sine and tangent is that when we get into the fourth quadrant, we're not going to say 5 pi over 3 or 11 pi over 6, but in fact, we're going to be using negative pi over 2, negative pi over 3, negative pi over 4, and negative pi over 6. So that's the adjustment we have to make with fourth quadrant. That's only with sine and tangent. With cosine, with arc cosine, we just reserve that first and second quadrant. Okay. I also want to review a little bit with reference angles. Okay, so you don't have to write this down. I just want to kind of talk about this real quick. Reference angles are angles that are created from the x-axis or with either 0, with 360, or with pi, with 180 or with 360. So for instance, let's say I said sine of theta is equal to negative 1/2. Right. So where's sine going to be negative? Which quadrant? 3 and quadrant 4, right? And these are all going to be variations of what? Sine is equal to negative 1/2. Is it variations of 30 degrees, 45, or 60? 30, right? So that's the thing that we want to kind of make sure that we understand is that when we talk about reference angles, it's always going to be these measures that are closest to the x-axis, right? So we know that sine is going to be -1/2 in the fourth quadrant. In the fourth quadrant, you're going to just always involve the x-axis and either add or subtract 30 degrees to get to where you want to be. So this is 360 degrees minus 30 degrees. So this is 330. And then the third quadrant will be 180 plus 30, which is 210 degrees. All right. So once we understand which, once we understand our reference angle, then we can find any place that we want to find, right? Either first, second, third, or fourth quadrant, depending on what sign we get, right? Okay, so that's important that if we're going to do this today with degrees and tomorrow with radians, right? But the idea is that we want to figure out what that reference angle is so that we can use that to figure out which quadrant that we want to be in, right? And we're always going to be either adding or subtracting from 180 or from 360. Or if it's the first quadrant, you just leave it alone. Okay, so those are two things I want to review before we jump into page 13. Okay, so we're going to give our answers in degrees. Today is degrees day. It says find inverse sine of 1/2 without a calculator. So this is uppercase S. We know that we're dealing with principal values. Positive means that we're dealing with first quadrants. Right, sine is first and fourth, right? We see a positive, we know it's the first quadrant. So sine is equal to 1/2, where theta equals 30 degrees, right? We can check in our calculator as well. So you get to use the calculator on the quiz, but sometimes the calculator doesn't give you everything that you need, but it's good to know where our calculator is helpful and where we need to kind of make our own conclusions. So you can do inverse sine. You can hit sine twice, so take it to inverse, and then do 1/2. Make sure you are in degree mode. So if you go to mode and the top row of buttons there, make sure your degree DEG is highlighted and blinking. 30 degrees, yeah. Everybody okay with calculators? Okay, so number 2, how would you solve inverse sine of 1/2 for all the angles between 0 and 360? So notice that this is no longer uppercase. So now we want to find all the quadrants where sine is equal to 1/2. So where else is sine positive? Yep, quadrant 1 and quadrant 2. You know it's going to be a 30-degree angle as reference angle. So you can figure that out, right? 30 degrees here. If I want 30 degrees in the second quadrant, I got to subtract from 180. So 150, yeah. So we're always involving 180 and 360, and you're either adding or subtracting whatever reference angle that you need. Okay, so 180 minus 150, sorry, 180 minus 30 is 50. Okay, so we have it. State the two answers for inverse sine of 1/2 equals theta. 30 degrees and 150 degrees. Find inverse sine of -1/2 without a calculator. So now we're talking about reference angle, principal values, because you see the uppercase S. So what would you say? Right, fourth quadrant, right? You know it's going to be a variation of 30 degrees, but we're not going to say 330 degrees. We're going to say -30 degrees, right? Because remember, the fourth quadrant is always subtracting from 0, right? So either -30, -45, -60, or -90. But try doing this in the calculator, and you're going to see that it's not going to give you, we have to do the reference angle. Sorry, we have to do that principal value on our own, because if you do this in the calculator, it'll return you a value that's between 0 and 360, right? I'm sorry, it will give you -30. With the calculator, got it. Sorry. Okay, so it will give you -30 degrees. But if we want the answer to be between 0 and 360, we're going to have to make that adjustment. Okay, so the calculator is going to give you principal values. And principal values is always going to be in the first quadrant from -90 to 90 degrees. Okay, so number 4, how would you solve inverse sine of -1/2 where theta is between 0 and 360? We know that, let's see, where's sine going to be negative? Quadrant 3 and quadrant 4. We know it's going to be involving 30 degrees as reference angle, so we can go back. If you have the diagram drawn, you can just remind yourself that you're going to be adding 30 degrees from either 180 or from 360, because we want our angle measures to sit between 0 and 360. Okay. So 180 plus 30, 210. And then 360 minus 30. Oh, sorry, I jumped the gun here. Third and fourth quadrant. So how do we find? We're just going to, I'll flip-flop these answers here, but basically we're going to add or subtract 30 degrees from 180 and 360. All right, let's not worry about the formula. I think we can kind of just reason our way through it. So let's skip number 5. Okay, are we okay so far? So I think it's really helpful, especially if you kind of get lost in what you're doing. It's always good to have a diagram, right? Just to kind of give yourself a little bit of an anchor. If you know that reference angle, then you can work your way around anything you want, whether it's something that's a principal value or something that's sitting between 0 and 360. It's going to be right there in front of you. Okay, inverse tangents. Find inverse tangent of 1. Another way of saying that is, where is tangent of theta equal to 1? What would you say? 45 degrees, yeah. Let's go ahead and check that with our calculator. We should get the same thing. Yeah. Number 2, how would you solve inverse tangent of 1 for theta between 0 and 360? Where else is tangent positive? Quadrant 1 and quadrant 3. Right, so you know that once you have that 45 is your anchor, because you can find anything that you want simply by adding or subtracting 45 from 360 or 180. We want something in the, let's see, how do you find this angle using the angle measurement found in number 1? We're going to add either add or subtract 45 from 360 or 180. Right, that's the general rule, but we know that because we're looking for quadrant 3, we're going to do 180 plus 45. Which is 225 degrees. So we know our two answers, first and third quadrant, 45 degrees and 225 degrees. Okay. Where is tangent of theta going to be -1? Which quadrant is tangent negative? Second and fourth, but we're talking about principal values. So we got to choose fourth quadrant, right? So what would you say? Guess, yeah, negative, right? -45, anything in the fourth quadrant. Okay, let's double check that, see if we get that in our calculator. Yeah, principal values. Question asked, why did your calculator give you that answer instead of 350 degrees? Calculator is designed for principal values here. So it's going to give us something between -90 and 90. Okay, so we know tangent is negative in the second and the fourth quadrants. How would you find these additional measurements between 0 and 360? We can just go to our chart, right? We know it's going to be one of these measurements involving adding or subtracting 45 from either 180 or 360. So we can do 180 minus 45. That will give us a second quadrant. In the fourth quadrant, we can do 360 minus 45. That will give us fourth quadrant. And 360 minus 45 is 315 degrees. Again, let's not worry about the formula. I feel like if you have this diagram in front of you, you can figure out anything you need to figure out. Any questions so far? Okay, next page, page 14. Okay, does anybody still need this page? No, you guys good? All right. Inverse cosine. We're talking about principal values. Cosine is going to be which quadrants for principal values? First and second, right? It's going to span the full spectrum. Only principal values for sine and tangent, we have to worry about the fourth quadrant and dealing with the negatives. Okay, cosine of theta equals to 1/2. That's first quadrant. Which angle measure is that going to be? Yeah. So tomorrow we'll do radians, but today we're sticking with degrees. So double check that with our calculator. I did 0.5 instead of 1/2, but same thing, 60 degrees. So once you know that reference angle, then you know everything that you need is going to be coming from this diagram. Either add or subtract 60 from 180 or 360, and everything you need is right there. Okay, so how will we solve inverse cosine of 1/2? Where else is cosine positive? We know quadrant 1 and 2. I'm sorry, quadrant 1 and 4. So first quadrant we already have. Fourth quadrant, we can do 360 minus 60. Because we want a measurement in between 0 and 360. So that'll give us 300 degrees. State the two answers. Okay. Where's cosine going to be negative? Or where's cosine theta going to be negative 1/2? Yeah. So what will this give us? What will we say? Yeah, 180 minus 60, which is 120, right? We should get that same thing in our calculator as well. Let's double check. All right, cosine is going to be first and second quadrant for principal values, right? Yeah, 120 degrees. Why did your calculator give you this answer instead of negative 60 degrees? Principal values for cosine is first and second quadrant, so between 0 and 180 degrees. So how would we solve where cosine is equal to negative 1/2? Cosine is negative in which quadrants? Second and third. So if we have this diagram in front of us, we can just deal with 180 and the 60 degrees, right? 180 minus 60 and 180 plus 60. questions so far? So now that we're moving into these examples where we're going to use the calculator to get to our reference angle, but it's really important that you draw your diagram so that you can just always involve the reference angle that you need. Okay, so right now we started with angles that you recognize from the unit circle, but now you're dealing with angles that you don't recognize, but the same process, right? Once you can find that angle, then it's easy. You just add or subtract from 180 or 360 to get to whichever quadrant you're looking for. Okay, so let me go through these examples first, make sure that you're comfortable with them, and then I'll leave you guys to try these other ones for classwork. Okay, okay, so let's start with part A. It says use a formula, but I just want us to use the diagram that we're going to draw. Okay, so it says inverse sine of 0.1736. It's basically saying when is sine of theta going to be equal to 0.1736? We obviously can't do this without a calculator, but the idea is the same. We're looking for sine values, and that's positive. What which quadrants are we going to provide our answers in? First and second, good. So sine of theta is equal to 0.1736. Sorry, this should be lowercase. So we know it's going to be quadrant 1 and quadrant 2. That's when sine is positive, right? Okay, so let's see what this gives us here. Make sure we do inverse sine, 0.1736. It says round to the nearest degree. 9.99, we'll say that's 10 degrees. So it's important that once you get that reference angle, that I think it's helpful to just go ahead and put your 10 degrees in all 4 quadrants so that you know whatever you're looking for, you're just going to be going through this formula. You're just adding and subtracting from 180 or 360. And that's how you get to your answer, right? You know quadrant 1, that's already 10 degrees. We already have that. So how do you think we can get quadrant 2's answer? 180 minus 10. Good, right? We want to move up, so 180. If it's third quadrant that we're looking for, then we do 180 plus 10. But I feel like I'm confident that if you can draw this diagram for every problem, you're not going to make a mistake because you're just always going to know what numbers you're dealing with, right? You're restricting yourself to just these numbers. Okay. And then just as a preview, tomorrow we're going to do the same thing, but tomorrow we're just going to be involving pi and 2 pi. Okay, these numbers will feel a little bit strange. We get strange decimals tomorrow, but if you have this foundation down, then tomorrow you just do the same thing. Just numbers are a little messier, but not going to change. Okay, so 180 minus 10 is what? Okay, go ahead. Okay, are you guys okay with that? All right, let's try part B. Inverse cosine. And in other words, cosine of theta is equal to negative 0.6427. Before we go any further, which quadrant are we going to be dealing with here for negatives? 2, 3. Okay, let's see what the calculator gives us in return. So cosine is a little bit trickier because we got to do a little bit more work, but if you understand what it's giving to us, then sorry. 0.6. Okay, this is the principal value, right? 130 degrees, right? 130 degrees. Let's go ahead and draw that. Let's see This is what it's giving us because it's coming from the principal values. What's the reference angle here? 50. Okay, so that is what we need to do with tangent. That is a little bit more work because it doesn't give you the first quadrant value, it gives you second quadrant value. You got to figure out what that reference angle is so that you can work your way around if you need to. Now you can find anything you want because you know that everything is going to be dealing with 50 degrees. Does that make sense? So you know 130 degrees is an answer because it's a reference angle. Sorry, it's a principal value. But then to get to the third quadrant value, we know we have to involve 50 degrees. So 50 plus 180 will give us what? 230. Yeah, so that's the thing that's a little bit trickier about cosine is we have to work backwards to figure out what that reference angle is so that and then from there we can decide which quadrant we want to live in. Okay, we're okay so far. I think sine and tangent are easier because everything they give you is in the first and fourth quadrant, so that reference angle is going to pop up in front of you without you having to do any additional work. Maybe just change the negative to positive, but cosine is going to give you second quadrant values, which can be, yeah, you just have to just know where you are. Okay, part C. Inverse tangent. Negative 2.7475. Okay, where's tangent going to be negative? Second and fourth. Okay, so if we plug this in the calculator, this will give us our principal value that we are going to use. Okay. Inverse tangent. Negative 70 degrees. Okay, so we know that is principal value. Oh, sorry, we know that's the reference angle, right? And then from there, we're going to create an angle measure that's between 0 and 360. So we're going to have to involve 360 and 180 to get to where we want to be. Okay, so how would you get to the quadrant 2 value? Mm-hmm. 180. 180 minus 70, right? We also want a quadrant 4 value. How'd you find that? 360 minus 70, right? Fourth quadrant, which is 290. Okay, good. So I feel like you're not going to have much trouble with sine and tangent because if you plug in the calculator, it'll give you a negative or positive version of the reference angle that you need. But just with cosine, if it's second quadrant, you got to, going backwards a little bit, figuring out that value before you work your way around the unit circle. Okay, how do you guys feel about that? Okay. Okay, so can you guys try the rest of this worksheet? And I'll put up the answers in a little bit, and then I'll go over any problems that you guys are missing or have questions about. Okay. Okay, so 1 through 9, go ahead and try those. Yeah, go ahead. I'll show the answers as I go through them.
Can you explain how you got to
So if you plug this in the calculator, it'll give you 29 degrees. If you know 29 degrees, that's really all you need, because that's the hard part, right? If you can get that 29 degrees filled in, then you're just figuring out which quadrant you want to be in. I want to be in the first and fourth quadrant. So I already have 29, I'm good there. So the other one is 4, so 360 minus 29. Yeah. Yeah, go ahead. Once you get that reference angle, just go ahead and put it in every quadrant. That way you just have a pattern to follow for every problem. Oh, I'm sorry, first and third, right? My bad. Is that making sense so far? I think the trickiest ones are the ones where you got inverse cosine that's negative, because it's going to give you a second quadrant value. You got to figure out what that reference angle is first, and then use that to help you find your way around the other quadrants. Mhm.
Isn't tangent?
But we're talking about negative though. Right? Where's tangent going to be negative? Second and fourth, right? So yeah, I always look at that first sign that at the beginning just so I can know where I'm going to be targeting my answers. I like to write those down first. Then I use my calculator to find that reference angle, fill in all my reference angles, and then I can take a step back and decide how I want to get to my angle measure. Okay, tomorrow we're doing the exact same thing, just instead of 180 and 360, we're using pi and 2 pi. And then instead of degree measures, you're dealing with radian measures, which just looks a little bit more abstract, but we're going to do the same thing tomorrow. Everybody good so far, 1 through 4? Okay, I'll continue working through. Everybody okay? Number 4? Okay, here's 5. Okay, so this is not going to spit you out the reference angle initially. You got to find that reference angle after you put it in the calculator. (113°). You know that cosine is going to be negative in the second and the third quadrant. So from that 113°, we got to figure out what that reference angle is, right? So we know what to do with it. But we know that's one of the answers. So what's the reference angle that's associated? 67. Go ahead and put 67 everywhere. Okay. We know ultimately we want a second and third quadrant value. We already have the second quadrant. To get the third quadrant, we'll do 180 plus 67. Okay, number 7. Number 8, careful. Second quadrant, you're going to have to figure out what that reference angle is. (162), 180, minus 162. In the corner, I'll just check this page for you guys.
All the other well, I know and I also some, I mean, they're not there's they're student I think